In problem 5, we're going to construct a confidence interval for a population proportion. In my case, it's an 80% confidence interval. In a survey of 36 senior business executives, 22 of them said that they felt that even if merit and abilities are equal, people with MBAs often get promoted faster than people that don't have an MBA. So we're going to copy this information, the sample size, the number yes, and the 80% into Excel. So we have the information pasted into the Excel spreadsheet. 22 senior business executives said they think that having an MBA helps people below them climb the corporate ladder. The sample size was 36 senior business executives, and my confidence level was 80% or 0.8. Now to turn the 22, which is a frequency, into a relative frequency, which the sample proportion is, we're going to divide the 22 by the sample size. So the sample proportion is 0.6111 or 61%. And what that sample proportion says is 61% of the business executives surveyed said having an MBA helps people below them climb the corporate ladder. This is the confidence interval for a population mean where sigma is known. We have x bar plus or minus z times the standard error, the ratio of sigma over the square root of n. In a proportion, the x bar is replaced with p bar, and sigma is p bar times 1 minus p bar, and then you take the square root of that. So sigma squared would be the inside of the root, p bar times 1 minus p bar. Since sigma squared is p bar times 1 minus p bar for a confidence interval for a population proportion, we multiply 0.6111 times 1 minus that value. So sigma squared is 0.237654 for my version of the problem. At this point, the confidence interval for a population proportion problem is identical to a confidence interval for a population mean problem with sigma squared known. The variance of the sample proportion is the sigma squared divided by the sample size, just as it was in a confidence interval problem for a population mean. The standard error of the sample proportion is the square root of the variance of the sample proportion. My confidence level is 80% or 0.8. My significance level is 0.2. Because a confidence interval has an upper and a lower tail, we have to divide the significance level by 2. The z-value can be found in the standard normal table, but those values are only to 2 decimal places. We can find z-values in the infinity row of the t-table. And we're going to find that z-critical value in column point 1 and row infinity. So I'll scroll through to the infinity row of the t-table. So we have the t-table up here. We're in row infinity and column point 1. So the upper tail has a probability of 0.1. The lower tail has a probability of 0.1, and we're in the infinity row. So we get a z-value of 1.282. With a z-value of 1.282, the margin of error, if you recall, is the z-value times the standard error of the sample proportion. The lower limit of the confidence interval is the sample proportion minus the margin of error. The upper limit is equal to the sample proportion plus the margin of error. So I am 80% confident that the true proportion of senior business executives who believe having an MBA helps people climb the corporate ladder is between 51% and 72%. Now we're going to copy these values into Cengage Now. The point estimate of the population proportion is the sample proportion, 0.611111. And we have to have 6 decimals, which we do. 1, 2, 3, 4, 5, 6. The standard error equals to 6 decimal places 0.081250. Now, the critical value for the confidence interval was found in the infinity row of the t-table. And it was equal to 1.282. And that's the 3 decimal places. The margin of error was equal to 0.104162. And I believe that is the 6 decimal places as well. The 80% confidence interval was 0.507 to 0.715. Both to 3 decimal places. Now I'm going to check my work, and I should get all green check marks. And I do get all green check marks. So in summary, we are 80% confident that senior business executives who believe having an MBA helps people get promoted faster than people without the degree is between 0.507 or 51% to 0.715 or 72%.